Domain and range are of two types: continuous, which is a smooth and unbroken line, or discrete, which is a list of individual points. The domain is a set of all the inputs, or the set of all the x values, while the range is the set of all the outputs, or the set of all the y values, which correspond to the given inputs. Let's look at the domain and range of a couple examples of continuous functions first. Suppose for a moment that this continuous function has endpoints at -7, -4, and +6, +2. The domain is a set of all the x values between -7 and +6. We represent this domain using inequalities. -7 is less than or equal to x, which is less than or equal to 6. We use the exact same approach to find the range, but we look at the y-axis instead. -4 is the lowest point on the graph, and +2 is the highest point on the graph. So the range is all the values in between -4 and +2. Again, we represent with an inequality. -4 is less than or equal to y, which is less than or equal to 2. One of the most important details to look for when writing the domain and range of continuous functions is whether or not the dot on the end is open or closed. A closed or solid dot means greater than or equal to or less than or equal to, while an open dot means strictly less than or strictly greater than. The domain for the example on the left stretches from -4 to +3, but does not include -4. So when we write the inequality, we use a strictly less than sign for the point on the left, but the less than or equal to for the point on the right. We'll do the same thing for the range. Since the range stretches from -3 to +4, but does not include the point -3, we write -3 is strictly less than y, which is less than or equal to +4. In the example on the right, the domain stretches from -4 to +2, but does not include +2. So we write -4 is less than or equal to x, which is strictly less than 2. Now it's very important to pay attention to the details. We always write our domain and range from the smallest value to the largest value. For the domain, that's easy because it's always left to right. But for the range, we must be sure we write from bottom to top. -3 is the smallest value in the range, so that number comes first, and that number is strictly less than all values of y. But all those values of y are less than or equal to +4. Problems like this one are always missed by students who aren't paying close attention to the details. Domain is written from left to right, range from bottom to top. Writing the domain and range of a discrete function is usually easier to handle because you don't have to concern yourself with solid and open dots or writing inequalities. All you need to do is list the points. Since this is a set of discrete or individual points disconnected from one another, both our domain and our range are going to be lists of numbers, and we prefer to write those lists in order from least to greatest. Here the x values are -4, -3, -1, 1/2, 2, and 3. The range is a list of all the y values, written in order from least to greatest. This is going to be a bit more tricky because we aren't looking from left to right, but from bottom up. Anytime your range repeats a value, as it does here, you only need to write that value once in the list of points. -3 is smallest, then comes -1, then -1/2, followed by +1/2, there's the repeated value, followed by 1. If the domain has a repeated value, then you're not dealing with a function, but that's a topic for another day. To sum up, domain and range come in two flavors: continuous and discrete. The domain is a set of all the inputs, or the set of all the x values, while the range is a set of all the corresponding outputs, or the set of all the y values. Continuous domains and ranges are written with inequalities, and you must be conscious of open and closed circles in the graph. Discrete domains and ranges are lists of individual points. Domain is always written from left to right, and range is always written from the bottom up to the top.